Hello, my name is Michael Maher, one of the members of the Experimental Hub team. I'd like to give you the final overview and demo of our project. During COVID, various labs began conducting remote experiments. One researcher created an experimental video conferencing platform called the Experimental Hub. This open source tool allows researchers to perform various online experiments.
Chloe Ektebas and her team are students at the Technical University of Munich working on security research. Chloe and her team created Experimental Hub, which is what our team's project will be using as a foundation. Experimental Hub allows experimenters to virtually host participants to conduct various HCI experiments, and these experimenters are given a lot of customization options to create an experiment of their requirements. And one of the most important features offered is filters. Filters can be applied to a participant's video to offer real-time manipulators and analyzers on their feed. And additional filters can be developed by using Experimental Hub's standardized development features, which is what our team is going to be working on.
Our team has implemented an rPPG filter for the Experimental Hub. It is a sensorless tool or method to measure heart rate via video. The only requirement is a high-resolution camera.
Hi everyone, this is Shushant and today I'll be explaining the rPPG algorithm. So rPPG stands for remote photoplethysmography. It's a non-invasive technique for monitoring physiological parameters such as heart rate. It relies on the principle that blood flow modulates the absorption of light and that can be measured using remote imaging devices like cameras or other imaging devices. rPPG offers the advantage of being contactless and which basically makes it ideal for various applications from healthcare to sports and wellness. However, it presents a unique challenge. It includes noise from the motion artifacts as well as the variations in skin tone can affect the accuracy. Next is the heart rate estimation using rPPG. So heart rate estimation applies mathematical algorithms to derive the heart rate from the processed data by calculating the most dominant frequency in pulse signal. It utilizes the features extracted in the previous stage to calculate this heart rate, and finally the output of the algorithm is a precise heart rate measurement based on the data acquired through the rPPG. Next we'll see a working demo of the rPPG algorithm.
Hi, this is Nishant and we will be going through the results. We have finished setting up Experimental Hub codebase and got the rPPG filter working as standalone feature and also integrated the rPPG filter as a part of Experimental Hub application. We have carried out set of extensive regression tests on error rate of rPPG algorithm for different image quality within Experimental Hub application. Moving on to the challenges section, team members initially faced some challenges getting the Experimental Hub running. We worked with mentors to sort this out. The team struggled to integrate the rPPG algorithm within the Experimental Hub's framework due to algorithm constraints. We were finally able to do this using our internal queue setup. The team successfully navigated the OMSCS program working in 4 different time zones, utilizing Microsoft Teams and scheduled meetings to maintain communication and collaboration.
Now on to reflections. Over the past semester, our team has been able to successfully implement the rPPG algorithm into the Experimental Hub. In the process, we also learned how to work with an existing active academic codebase and are actually in the process of merging our heart rate filter into Experimental Hub's main branch. In implementing the algorithm, we've also learned about how face match detection, the Lee CVPR algorithm, and color processing all work together to detect and output real-time heart rate monitoring. Finally, from our real-world testing, we found that lighting conditions like warm versus cold light temperature and background lighting have a great impact on HR detection by the algorithm. To continue reflections on the project, we can move on to our goal accomplishments. We initially set up to integrate the rPPG algorithm into Experimental Hub, and I'm happy to say that our team has accomplished this difficult goal. Additionally, we were able to go beyond our original scope and test out various lighting conditions, as well as an important factor to consider in testing, which is subjects wearing glasses and its effect on the algorithm. Finally, with our team's work, the foundation has been laid for future integration of physiological data into virtual meeting platforms.
For our demo, I have 2 web browsers running. The window on the right shows the Experimental Hub from the researcher's perspective with an ongoing experiment with 3 participants. I'll be joining here. And on the left side, I'll be joining as a participant with the rPPG filter applied to them. You can see that my video feed shows up on the participant window, and then it will show up on the researcher's window with the filter applied. So here, if you look closely, there is a face mesh RY applied on it, and then if we wait a few seconds, we'll get the heart rate calculated through the rPPG algorithm.